Okay, hey everyone. I'm Rajan Mistry. Welcome to the session. I think this is the final session for the day, right? So how many of you are excited for the evening party? Yeah, yay. How many are excited for this session? Good, good. So my name is Rajan. I am a senior software engineer with Qualcomm. I have Ash with me today.
Hi.
Yeah, good.
I'm a software applications engineer. I work under Rajan.
So we are part of developer evangelist team at Qualcomm, and we work across these different initiatives that Qualcomm has to kind of enable developers build applications on top of Qualcomm platforms. So I just wanted to kind of scan the room and see how many of you are actually doing Android app development, actively doing Android app development. Almost all of them. How many of you actually have AI integrated into your app? One, two, okay. How many are still looking into AI? Like looking into AI, want to build something, still figuring out how it applies to your use cases and whatnot. So hopefully we'll be able to share some more information around that, how you can use some of the tools and architectures that we have to integrate AI into your workflows, what that means in terms of use cases, what tools we have, and it'll be a little bit of interactive. We will have instructor-led session. At some point, we will switch from a presentation to the actual platform and go through the workflows. You guys can feel free to follow along. We'll have some barcodes along the way. You can scan them. You can save them, bookmark them. Do it later if you want, or if you want to kind of log in and follow along, you can do that as well. So. There was an overall agenda, which I just covered. So as Qualcomm, right, like I said, our team mainly focuses on enabling developer ecosystems, and especially with the proliferation of AI, right? So we see a lot of these AI use cases for app developers, not just enabling AI into your apps, but also how AI is improving the developer workflow, right? With Gen AI, right, is almost low-code to a no-code approach where you can use these LLM large language models that are already integrated into your IDEs, and they are simplifying your workflows, making it easier to code, making it easier to deploy as well. With that, on-device AI has been a big focus for Qualcomm, right? So Qualcomm, we have our origins from the smartphone, right? So we build Snapdragon chipset that goes into smartphones, and those phones have a lot of enablement for AI, right? So imagine you have your camera, how much AI happens on your camera when you're taking a picture. Yeah, you have bokeh, you have background blurring, and a whole bunch of AI that you are kind of running on your smartphone. We are taking that and scaling it across different use cases. So whether it's automotive, XR, IoT, robotics, drones, all of these different use cases kind of benefit from the same core technology enablement we have done in mobile, and that spans across these different use cases. And that spans across industries. So with that, what we have seen is AI inferencing is kind of moving from cloud to end devices, right? So AI on the edge. We have, of course, for training your AI models, cloud is still the go-to. You're training your models on the cloud. But you are actually, when you are deploying it, you're running the AI inference on device. There's a lot of reasons for that, right? Privacy and security is primary. A lot of use cases have restrictions on what you can and cannot do with the user data. You can't just dump everything to the cloud. There's latency issues. You need to be mindful as you are building your applications to run the AI locally on device. Having said that, hybrid AI is also something that we are heavily invested into. A lot of use cases will be where you can do some basic AI inferencing on device, but then for larger models or larger LLMs, you might still rely on that cloud service to go and give you the inference results. One of the reasons we truly believe AI, running AI workloads on the edge devices is going to be key is because we believe AI is going to be the new UI, right? What we mean by that is you have these agentic AI. How many have looked into agentic AI, like workflows? Yeah. So, yeah, 2, 3. So what this means is a lot of these edge devices that are capable to run large language models on device will have some sort of a AI agent that is already running on device, that's a LLM, that is actually the user interface into the device, right? And then all of those agents will tie into those end applications, right? So and those end applications will in turn benefit from that AI. So those end applications are not actually deploying large language models on device, but the LLM is actually tying into those applications, right? So you have a finance app. You have an app that lets you book concert tickets. So all of those apps, you can just call your AI assistant, hey, can you book me tickets to XYZ concert that's on 2nd of October, and I need 4 tickets, right? It'll give you options, and it'll automate that process for you. So that's going to be a big shift in how end users are using these end devices, and hopefully it will enable a lot of those use cases for app developers also. So I want to quickly touch base on, I mentioned earlier we have a lot of these AI workloads running across these different platforms, right? Whether it's XR or IoT or automotive. Some of the enablements that we have done or invested in over the past couple of years, this kind of lays out the architecture for that, right? You can go from collecting your data to actually training your model, testing your model, and then deploying it on an end device, all within the Qualcomm ecosystem, right? So we have Edge Impulse. It's a platform that we acquired, which helps you, as a platform, implement that whole process, right? So that's something that we'll be doing hands-on today, right? We'll go through the whole Edge Impulse workflow, show you how you can actually collect some data within the Edge Impulse platform, train that data, test that data, and deploy it on end devices. And then once you deploy it on end devices, those devices can be anything, right? Those can be your smartphones, can be your IoT devices, can be your vehicle that has an app store or whatnot. So Edge Impulse, right? So what is Edge Impulse? We want to start off with that. Just want to introduce you to Edge Impulse. Edge Impulse is basically an MLOps platform. It's basically enables your development team with an end-to-end workflow, right? You can train your data, collect your data, use that data to train your model, and deploy it on end devices. But it's also a MLOps platform it actually gives APIs, right? So it has a pip install. You can just pip install Edge Impulse. It has Rust APIs. And you can integrate the platform into your CI/CD workflow, right? So if you have a team of developers who is collecting data, training your model, testing the model on end devices, you can manage that whole pipeline as APIs, right? You can then integrate into your CI/CD pipeline and go from end to end using the platform. So the barcode that you see on there is basically the login to the platform. If you want to follow along, you can sign up to Edge Impulse, and then we have some sample apps that we'll go through. You can follow along with that. Anybody interested in that, feel free to take a picture. It just goes to edgeimpulse.com/signup, and then you can do that. So that's the overall workflow that we'll cover today. We'll collect some data, or we'll actually show you how to collect the data, talk a little bit about what the platform enables in terms of training, what kind of use cases you can train with the platform. Once you train the data, how you get the download, how you can set up the Android environment for your sample applications, and then actually test the sample application using Edge Impulse. So that's hopefully we'll be able to cover that end-to-end workflow in today's session. So we can switch to Edge Impulse. We can start with data collection. Right. Yeah. Right. So basically, the first step to your AI, to building your AI app, right, is, and for your use case, any use case you have, is train your own model. If you're not using an off-the-shelf model, there's a bunch of off-the-shelf models that you are using, but if your use case is very specific, where you want to collect your own data and retrain your model based on that data, you would start with data collection, right? So for collecting the data, there's two aspects to it. One is the actual device and the data. So we can start off with the device.
Yeah, so once you have signed in, so you have your dashboard. So on the right side, if you click, you have an option to create your new project. So that's how you would create your new project. Once you click on creating your new project.
So sorry, hold on. So before you go to projects, right? So devices and data acquisition. So on the left-hand side, if you see, you can basically convert any device into a data collection device, right? So whether it's your Android smartphone or your IoT device or your wearable device that's giving you IMU data, you can get any data from these devices and collect data from them and then train that using those devices, right? And you can connect multiple devices to this platform. So if you have a dev team where a bunch of folks are collecting data, you can just keep adding those devices, and all of those devices can go into the platform. So by default, Edge Impulse as a platform, there's two different versions. So there's a free version and there's an enterprise version. Free version gives you 2 private repositories or private projects that you can use. So if you want to kind of commercialize your AI model, train your own data and test it and deploy it, it gives you 2 private repositories that you can then commercialize. And then it gives you unlimited public projects that you can just train, test, share with the community, and go on. And once you collect data from these devices, then you can, there is a data acquisition. Yeah.
So on the right-hand side, if you click on the connect a new device, so either you can use your phone, like to scan the QR code, or you can connect to your computer or any dev kits that you are working on. You can directly link it to your dev kit and start collecting the data. So in this case, I would actually tell you to just so I would suggest you that in your project, connect to a new device and scan the QR code on your laptop that you are able to see. And that's when it just asks you to permission for your camera. So once you take that permission, and then you can start clicking pictures. Like you can try this project over any water bottle or anything that you have in front of you. You can just click multiple pictures. And then when you go to the data acquisition page, you can start seeing that data being accumulated here in real time. So once you see that happening, you can start labeling them. So for any object that you have cleared, you can start drawing boxes around it and start labeling them. So for the different parameters you have, by default, you have different colors that will come up. So you can just select the box and draw around it, draw a box around it. Once you do that, then you can go to creating an impulse. So here, as we would be using our phone, it would be more or less the image data that you're collecting. So you can just select the image data. So the platform offers multiple types of data. That is one being image data, and the other one being audio, and even time series data. So it can be any of these data that you would want to collect. Once you collect them, you can specify the width and height of it, and like you can change all of these models.
So in case you were wondering the image before, what we tried to do is we tried to train a model to play Jenga, right? So we took an edge use case where we took 3 different states in Jenga, like remove a block, there's an empty block, or there's a stable block, right? So those 3 kind of things we kind of trained. We collected a bunch of data. How many images did we collect?
We collected around 364 sets of data. Like it's just images, and we manually like drew boxes around it. There's an option of even like plugging in your data set if you don't want to manually do it. Yeah. So once you do that, then you can go to create impulse. Yeah.
Impulse is what we call the actual model, right? So when you create an impulse is when you are actually defining what it is that you actually want the model to do, right?
Yeah. So here, like in the image and the object detection. So these 2 are the things that you can play with your whole project. So one is adding a processing block. In this case, like because it's an image data, right? So if you want to change the background or change the audio, like remove the noise cancellation or add any of your own processing block, you can do that as well. So if you click on the add processing block, you can either choose from whatever is already available, or you can bring your own DSP code. So both the options are available. And after you finish that step, the main step, that's the ML AI model. So as this is image data, it would be mainly object detection model. There are multiple like models that are currently available, and this is optimized based on like whatever end user that you are going to select on. So these are the things. So if you have click pictures using your phone, because it's image data, you can just select any object detection models that are available here.
There's also visual anomaly detection. So object detection is one where you can just train it to detect objects, whether it's birds, whether it's bottles, water bottles, cups, keyboards, and whatnot. Visual anomaly is where you can actually detect anomalies. So if you have cracks and stuff like that, where those are kind of corner cases that you can train a model to detect and build an application around that. And we use visual anomaly for this Jenga.
Yeah, so we use the vision. So mainly for using the vision anomaly for the Jenga project is that the Jenga blocks are all of the same color. So it's very difficult to picturize that. So to kind of get that out, so that's why we use the visual anomaly detection for this. So based on the use cases, you can select any of the models that is there. Here also you have an option of bringing your own model. So in bringing your own model, what happens is like you can use your PyTorch, Keras, or Skillet-learn, or even like your Onyx model. So you can, there's detailed documentation on like what are all the different models that you can bring on and how you can bring it. So for MCU-based and for Linux-based, so there is like both options are there on the platform. So you can, and they are pre-built. Some are pre-built, and some you can make it as custom as well.
So how many actually have your own models today? I know very few of you are actually building apps, AI apps. How many actually have like a model and a use case that you're already looking at? How many of you are looking to collect your own data, or it's interesting for you? Okay, yeah. So even for your pet projects, right? Because I know my neighbor has a bird detection. So he has some bird feeders that coming to his bird feeder, and he trained a model to kind of detect some birds that are kind of endangered. And he has a hill that he can see from his backyard. So he wanted to make sure one of the endangered birds he captures, so that he can send it to the city officials and make sure they don't do development on the hill that's next to him, and he doesn't lose the view. So those kind of use cases, even if you are like your pet project you want to do, you can do. So yeah. You can train it on your own model, you can bring your own model, or you can collect your own data and create your own impulse. Yeah.
So And not necessarily that you should just have one model that's running. You can do a combination. Multiple blocks and multiple models can be running simultaneously with this. Like you can, with the existing model, if you want an extra feature added on, you can just add that as an extra block. So once you are done with this, then you save your impulse. Then you go for like the object detection section. That's 2 steps below that. So here you can kind of change the number of training cycles, the learning rate, the training processor. So you can either select like the CPU or GPU, and then you can change the validation, batch size. So you can change these and keep saving and training the model. So as long as like your number of training cycles is not too big, it is pretty quick. Like once it reaches a big cycle, it takes a minimum amount of time to train. So once you train it, you can, the parameters that you can see is like the precision, recall, and F1 score. So once you have a decent score that you feel that you can test on, we can move ahead to the deployment mode. So in the deployment mode, like if you have done these steps, you can directly launch in the browser and see how your model is working, even without having this, even without having the zip and running the whole model, you can just launch it. Like everybody who creates a project have their own QR code that's running. So you can just launch it on your browser and start seeing it. In the deployment option, you have like multiple models that you can deploy it on. So like this is like C++ library, TensorFlow Lite, or the Eon tuner that's like custom made. We have multiple, sorry.
This will depend on your target device, right? So depending on what target device you have, you would select, yeah.
Yeah, so this would mainly depend on different target devices. We have multiple sections here, like where you can decide on what you want to do. Once you're done with it, like when you download this file, it comes as a zip file. So when you open the zip file, you have an Edge Impulse SDK, and you have the TF Lite folder, and you have another folder. So these 3 folders, you can directly plug in to a GitHub resource that's open resource for from Edge Impulse. So clone this project to your laptop. So the main resources that you would be needing for this would be an Android Studios and just.
So this is where we would kind of take the output while we got from Edge Impulse, right? You got the model, you have the data, you got the model, you downloaded the model, and now we will take a sample app that's freely available on Edge Impulse GitHub, and take the model and plug it into the sample app, right? That's the next step. So you download the zip, you abstracted it, you git clone the sample app, and then you integrate it.
So once you git clone and swap these, you can directly install the APK onto your laptop and plug it to your Android device and see it running in real time. So that would be on device without any cloud as well. Like you can see the model running. This, in the free account, you get like unlimited number of public projects, but only 2 private projects. So you can open this and start seeing how this whole thing works.
So the sample app, just want to touch and go back and touch on the sample app, right? So there's some prerequisites for the sample app, right? Android Studio for that's a no-brainer, right? That's what you would use to kind of compile and run your project and get an APK out of the sample app. There's Android NDK, right? So the Android NDK is going to help you with the C++ library, right? So you have downloaded the Edge Impulse, that's the TF Lite model, and whatever the model output you are getting, you would need to build a C++ code that would understand that output, right? And that's where the Android NDK would make it easier for you to interpret that, right? So with Android NDK and the Edge Impulse SDK, it makes it easy, super easy for you to kind of read what data is coming out of the model and integrate that into your application. So those 2 are the main ones, Android SDK, Android NDK, and
Android Studios, and you have to just git clone the Git repository. So similarly, as this is an Android app, we even have a Git repository for the Wear OS, so where you can directly install the TF Lite and the Edge Impulse SDK models from the deployment phase, and you can just swap the files, and that can work on the Wear OS device. So both of these are there. In the GitHub resource, you can git clone it, and you can also change the code based on your needs. That's pretty much how this works. So in the GitHub resource, mainly like it's a sample app. So it's for a crack detection app that is there. So if it's a more complex project, definitely you would have to work on that. But if it's a small scale project, then it's good. Like you can just swap the models and you can see it running on your device.
So with the 300 images or 300 plus images that we took, right? So what type of accuracy did we get for that Jenga project? Right, detecting remove blocks, empty blocks, and stable blocks. Like what type of accuracy are we seeing?
Yeah. So based on different models that we train, we get different accuracies. The best that I got was around 80%. So even in the train and test split, you can kind of divide how you select the data. So one of the main things that plays in your model is how you divide the data set. So if it's equally divided, then you can have a better accuracy. If the data set is not very diverse, then definitely you're going to have issues with how it's going to detect on your phone. So you can even change the data, like the train and test split. So you can change all of this in your model, like based on your necessities. Anybody have any questions?
So so I think we got interrupted and thrown off a little bit. The actual presentation is on the other laptop. We had a couple of last call to actions slides that we had there where, it pointed to the actual Edge Impulse sample app with edge detection that you mentioned. We have also published this as a project on qualcomm.com/developer, where you can follow all the steps of kind of training, collecting your Jenga data set, training it, testing it, and deploying it. That's all documented. It's all publicly available. You can clone that project on Edge Impulse and test it out. As a final one, we also have a bunch of actual Qualcomm employees that are helping developers. So as a last call to action, I would encourage everybody to join the developer community. I think we are on Discord. You can join the Discord if you have any questions around AI model training, any of the Qualcomm tool chains or Edge Impulse tool chains. We have our support team, actual Qualcomm SMEs answer questions on the Discord forum, and then sign up for newsletters if you want to be in the loop, be in the know. And then we have a bunch of tutorial videos on YouTube. So Edge Impulse team is really great at doing this also. They have a bunch of tutorials you can get started with. And yeah, hopefully this will enable you to kind of start thinking about how you can integrate AI into your applications. Computer vision is just one use case. Like Ash said, you can also take data from your wearables, and whether it's fall detection, whether it's audio-based use cases, you can train the models to detect some anomalies in audio, if somebody has fallen down, any computer vision-based stuff. So all of these different use cases, you can start kind of building apps around that. So.
There's even Edge Impulse Discord, and they have their own GitHub. So in their Discord channel and in their forum, there are a lot of people who are working on different projects. So they have a live communication of like what they're working on, and there's a lot of sharing of the data set that is happening. So this helps in the community building as well, to kind of understand what's going on and how and what people are building. So that's a very like live and communicating channel. So there are a lot of projects that you can see that are already built on top of it.
Awesome. Any questions we can help answer?